Thanks to the capabilities of modern smartphones, handheld augmented reality is a rapidly growing application field. In handheld AR, users interact with an AR scene with their smartphone in their hand. Extending handheld AR with a mid-air pointing device like a pen enables new unique possibilities to create and interact with virtual content embedded in the real world. In normal handheld AR, users can touch the screen or move the smartphone itself. But when we add the pen, they can also specify a three-dimensional point in mid-air and use the surfaces of their physical environment for interactions. However, many fundamental interaction design questions have not been evaluated yet for this kind of bimanual interaction. This includes menus, which are an essential component in most visual interfaces. Today, it is unclear how to best interact with them in this setting. To address this, we implemented 5 methods to interact with basic menus in handheld AR with a pen. The first method, called two-handed touch, is the current standard in handheld AR and our baseline. You hold your smartphone in one hand and touch the screen with the other. The second method, called mid-air pen, lets you use the pen in mid-air to interact with the same menu. In the third method, called one-handed touch, you hold your smartphone in one hand and use the thumb of the same hand to tap on a menu that appears within reach on that side of the touchscreen. In the fourth method, called device pointer, you see a cursor on the smartphone. You move and rotate the smartphone until that cursor highlights the menu item you want. Then you confirm by pressing a button on the pen in your other hand. The fifth technique, called surface menu, uses the haptic properties of the physical environment around you. The menu is rendered onto an existing physical horizontal surface in front of you. You select items by tapping them with a pen. We compared these menu techniques in the study and measured the successful selections, the time needed to select an item, and the required movement of the smartphone during the selection process. We also asked our participants to rate the ease of use and comfort of each technique and to rank all 5 techniques. Participants favored the current standard of two-handed touch menu, followed by the one-handed touch menu and the mid-air pen menu. All techniques achieved good selection precision, and two-handed touch, one-handed touch, mid-air menu, and device pointer achieved similar selection times, with two-handed touch being the fastest. The surface menu, on the other hand, took longer. If the interaction consists mainly of selections and takes place on the touchscreen, use a standard two-handed touch menu. If the interaction takes place mostly in mid-air, consider one-handed touch and mid-air pen menus, because their performance is close to two-handed touch menus, and users don't have to move their hand holding the pen from behind the phone to the touchscreen and operate it while holding the pen. If you want to preserve the current context of a mid-air interaction, but also support quick routine menu actions, consider using device pointer menus. In most cases, the context switch to move the pen down to a surface menu is too costly. But it could still be useful if the interaction right before or after it benefit from the guiding properties of a physical surface, like with handwriting. In all, our work provides first insights into how to interact with menus in handheld AR systems with a mid-air pen.